Today's section is 1.5, division of segments and angles, and really just a fancy way to say that we're going to be dealing with bisectors and trisectors, ways that we can divide angles or segments into smaller pieces. So getting into those definitions, a bisector cuts an angle or segment into two congruent parts. Now here's how you can remember what a bisector does. Break apart the root words. We have bi and sector. Bi means two. Bicycle's got two wheels. And sector means pieces. So a bisector cuts it into two congruent parts, whether it's a segment or an angle. Now usually we'll just call it a segment bisector, but if it happens to just be a point, we're going to call it a midpoint because it's going to break it apart into, it's going to be at the middle of the segment. Similarly, we also have a trisector. And just like bisector, the root words tell us what it does. Tri means three, tricycle. Sector meaning pieces, so three congruent pieces. Trisector cuts an angle or segment into three congruent parts. Here's what they look like. Segment bisectors, they can be a number of different ways. If we look at this segment right here, it's been bisected by a point, and that's called a midpoint. And we know it's been bisected because those little tick marks tell me AC and BC are the same. Down here we have a segment or a line that's been bisecting segment AB. So it's taking segment AC and CB and they're going to be congruent. But now we have a bisector that's an entire line and not just a point. So C here is a midpoint, and down here we have a bisector. Over on the other side we have an angle bisector, and I think these are more difficult to visualize, but when you have an angle BAC, if this ray is cutting it in half, then we're going to mark off that we have those congruent pieces. So those little tick marks on those smaller angles mean that they're congruent. So let's get into some examples. Our first example, we have that TE, the ray, bisects angle STW. And again, looking at our root words, bi meaning two, sect meaning pieces. So TE is going to break up this angle into two pieces. So let's mark them off. But those are the same. And the nice thing is I'm given the measurement of both. So I'm told that angle STE is 4x minus 5, so that's this angle right here. And I'm told that WTE is 2x plus 17, that angle right there. And what I'll do is I'll set those equal. And then solve for x. Now there's more x's on the left-hand side, so I'm going to bring 2x over to here. So 4x minus 2x. And then I'm going to add 5 to the other side. And when I divide by 2, I get x equals 11. Now, we want angle STW, so there's a couple ways we can do that. Now, that's the entire angle. So one choice is we can plug it into either one of our angles, find out what it is, and then double it. Or we can plug it into both angles and just add them up later. It's really our choice. So I think I'm going to do the method where, because it breaks it into two equal pieces, I'll find one piece and then just double it. And I think the easiest piece would be to find the measure of angle WTE. And the reason I think it's easier is there's no subtraction, just addition. The numbers seem a little bit easier to work with. So 2 times 11 plus 17 is going to give me 22 plus 17, so 39 degrees. I want STW, which is the entire angle. It's made up of 1, 2 equal pieces. So the measure of angle STW is double 39, which is 78. And there's my angle. Again, the other choice was to plug it into STE. You should see that that's also 39. And when you take 39 plus 39, you get 78 as well. Alright, now we have a proof. Now the proof says that we are given that LR and LA trisect angle ULA. So what that means is that all of these pieces are congruent. Trisect meaning three parts, three congruent parts. ULR, RLA, ALT. Now the nice thing about this proof is I can pick any two pieces and they should be the same. Alright, so let's see, LR and LA trisect angle ULA. So that's my given information. Always start your proofs with your givens. Alright, and now we know because we have a trisector that by the definition of a trisector we're going to have three congruent parts. So I know that all three of these pieces are the same. I picked out these two, so I picked out ULR, which is this guy right in here, and I also picked out ALT, which is this guy right in there. So in my proof, I'm done actually. I'm going to say that ULR is congruent to angle ALT, and my reason, I'm going to say an angle trisector. Notice I'm using abbreviations. Angle, I'll just use the angle symbol, trisector, TRI, cuts an angle into three congruent parts. Now I only use two of them, but I still use the definition that it cuts it into three congruent parts. And there's our proof. So we start off with our given information, we got to our proof, we're done. Now I love this problem. This problem is going to tell us here that we are given a segment with a measurement. It's going to give us two smaller pieces and have us figure out if it is the midpoint of PO. And here's what I love about this problem is there's many different ways that you can do it. So one way to do it is you can take the two smaller pieces, PR and RO, and add them up to 34. If PO is 34, then they have to add up to 34. And then from there you can take your value of X and see if they're the same. So I'm going to do it that way first, and then we'll show another way. We'll do 3x minus 1 plus x plus 7 equals 34. I gotta fix that 1. That's not a nice looking 1 there. Alright, let's make that better. So add these up, we get 4x plus 6 equals 34. Now to solve this, I'm going to take away 6 and divide by 4, and I get 7. Now once I plug that in, I'm going to see that PR and RO are the same, and if they are, then it works. So PR is going to equal 3 times 7, which is 21. Take away 1, and I get 20. And I'm going to set it 7 into RO. 7 plus 7 is 14. We have a problem here because in order for R to be the midpoint, these two segments would have to be the same. They would both have to be equal, and they're not. So in this way, I'm going to say no, PR is not congruent to RO, and that's my justification, a reason. The work has got to be there as well. It's just not simply a yes or no question. So that was one method. Take the two smaller pieces and then add them up to 34. Here's another method. If R is the midpoint of PO, that means that PR and RO have to be the same. So what I could do is take 3x minus 1 and set it equal to x plus 7. Now when I solve for x, I'm going to bring my x over here, so take away x on both sides, gives you 2x. Add 1 to the other side, which gives you 8. And you divide by 2, you get 4. Now from there, that's great, I got a value of x, but it doesn't mean much. So I'm going to say that PR, I'm going to find out what it is. So I'm going to do 3 times 4, which is 12. Take away 1, gives me 11. And then I'm going to do RO, 4 plus 7 is 11. Now you might think, hey, it's a midpoint because they're both equal. Well, not really, because you made that assumption that they were going to be equal. What I have to do next is test to see if these actually add up to 34. So if I do 11 plus 11, I don't get 34, I get 22. So my answer is still no. The problem hasn't changed. And that's because PR plus RO does not equal PO. It's supposed to. And it doesn't. And that's a problem. Alright, now your other option is knowing the fact that if this is 34, then each of these segments, PR and RO, if it is the midpoint, they've got to equal 17, which is half of 34. So I'm going to take each part and set them equal to 17. When I solve for x, I'm going to add 1. I get 3x equals 18. And divide by 3, I get x equals 6. And here I'm going to take away 7 and get x equals 10. This is a major problem. We've got two different variables for x. So this cannot work because x cannot be 6 and 10 at the same time. It's impossible. So again, a lot of different ways to do the same problem. The justification is the important thing. Show the work that leads to your answer, and then be able to provide a reason that it is or it isn't a midpoint. And we're done for the notes.